Good morning, good afternoon, good evening, whenever you're watching this video. I hope you're having a good day. In this video, what I'd like to do is discuss three when questions related to descriptive tables. When are they used? When are they not used? And when do we typically modify them? So the first question, when do we use them? Well, if we look at this table 1 that I presented, where I cross-distribute number of variables with type of analysis, we see that we've got, 12 cells, 3 by 4, and descriptive tables exist in 1, 2, 3, 4, 5, 6, 7, 8 of the 12 cells. And so the reality is we use descriptive tables a lot, regardless of the number of variables and regardless of the type of analysis. We're likely to use a descriptive table. What I need you to understand is this table isn't exhaustive. We could probably also put descriptive here and associative. It's just not going to be the main focus. So we may or may not choose to use it. When do we not use them? Okay, this is where it gets a little bit tricky. If I am doing a purely qualitative study where I am writing a narrative dissertation, the likelihood of using a descriptive table drops dramatically. And so there may be no use for creating a descriptive table. If I am creating a model, I may not choose to use a descriptive table because that information is common knowledge and therefore isn't needed. So if I'm working with old data, let's say, for example, an extant data set, the descriptive statistics for that data set may already be common knowledge, and therefore your chair, your committee may decide not to do it. You know, we don't need this, we can find this from a secondary source. That's up to you and your committee. That's where you negotiate with your committee. I always tell people better to err on the side of fault. Build the table and then negotiate retaining it or not retaining it in your dissertation. It's always easier to take something out than later having to put it back in. Last question, when do we modify them? Once again, a tricky question. You will run into some professors who will say, I only want to have your continuous data in a descriptive table and your categorical data in a frequency distribution table. You'll run into other professors that will say, I don't care, just put it all on the same table. This is where you start running into scenarios where gender is given a value of 0.6 with a standard deviation of 0.16. Now, those of you who are looking at the screen right now and going, how do you quantify gender? You're right, you can't. It would actually be read as a percentage. You know, if they said that the average gender was male 0.6, then really what you're saying is 60% of your sample was male. And it then becomes a probability. The probability is 60%. And this is why some professors do not like it when you combine both categorical and continuous data. If we scroll down to this table, this is a univariate descriptive analysis. Everything is continuous. I've got the mean, median, and mode. That's the center. I've got the standard deviation and the range. That's the shape. I apologize, the spread. Then I got skewness and kurtosis. That's the shape. So center, spread, and shape is right here. If I tried to put in a frequency distribution, what I would really need to do is put some sort of break, and then you'd put that information separate and apart, because this stub or this header no longer applies to the information that I would put down later. So some professors say, no, just make two different tables. Other professors say, I don't care, put it all on the same table. This is something that you have to negotiate with your chair, and it gets a little sticky. If you like to get in these kind of arguments, well then do so. If you don't, then just make two separate tables. A frequency distribution table for categorical data, a descriptive table for continuous data. I hope this video has answered some of your questions. Hope it's raised some. If it has, please let us know. Otherwise, have a good day.